Now then, as most, if not all folks know, the metric and SI systems are based upon base 10 logic and multiples and submultiples of 10. The millimeter is 1/1000th of a meter, the centimeter 1/100th of a meter, the meter, the base, and the kilometer is 1000 meters. Whereas the imperial/customary system has 1 inch, 12 inches is 1 foot, 3 feet is 1 yard, 1,760 yards is 1 mile, and, just for my point, 3 miles is 1 league. Now then, before you start making hasty conclusions, I want you to notice a different pattern. 12 can be halved, thirded, that is divided evenly by 3, quartered, that is divided evenly by 4, and sixth, that is divided evenly by 6. 3, the quarter of 12, 1,760 can be quartered, and 3. Allow me to introduce you to the values of base 12 logic and multiples and submultiples of 12. A brief overview of them, that is. After thoroughly examining base 10 logic, you will see that it is annoyingly limited. 10 has only 2 possible factors, i.e. 2 and 5. These numbers are very limited. Both are prime numbers, thus cannot be further divided, and 2 is very small to work with. Pro-base 10ers and pro-metric/SIers will claim that its moving of decimal points after multiplication or division is an advantage, but this characteristic is not exclusive to base 10. It's not because it is 10 which provides this characteristic. Technically, it's a characteristic which all bases have. It's a characteristic of the place value notation which we use for expressing numbers, which is assisted by the 0. Base 10 has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In base 10, 6.6 times 10 equals 66. Base 12 has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, dec L do. Dec and L are special symbols which represent 10 and 11 respectively, symbol digits, and the 12 do is written as 10. In base 12, 6.6 times 10 equals 66. However, in base 10 value, that would be 78. First point, 12 is a very composite number. It is the smallest number which exists which has at least 4 divisors, i.e. 2, 3, 4, and 6, whereas the number 10 is limited to only the numbers 2 and 5. Second point, 12 is much more practical for working with fractions. Dividing weight and measurement into 12 pieces, specifically halves, thirds, quarters, and sixths, is easy. Third point, by use of base 12 logic and/or using 12 as a multiplication/division base, which the imperial system uses, one can use 3 of the most common fractions, specifically halves, thirds, and quarters, without needing to resort to fractional notation, decimals, and/or percentages, because the results are integers, whereas with base 10 logic and/or using 10 as a multiplication/division base, which the metric and SI systems use, one must deal with fractional notation, decimals, and percentages, e.g. 1/2, 0.25, and the worst of the lot, that really annoying ad infinitum, 33.3 ad infinitum percent, aka 0.333 ad infinitum. Now then, as a side note, a pound to an ounce has the base 16 advantage. The fact that the metric system may be great for conversion is insignificant in situations where conversion is not needed. For example, there is no need to convert from square feet to square miles for house purposes, and there is no need to convert from miles per hour to yards per second for traveling purposes. Conversion is useful in only specialized situations, which most folks never see. The fact that Celsius is based upon the freezing and boiling points of water is completely insignificant when measuring something else, e.g., body temperature, the freezing and boiling points of any other substance, the AC, the weather, etc. Most everyday things, like a candy bag, aren't at all important. What's the big deal whether a customer buys a candy bag in pounds or kilograms? Will any computer or any other such important equipment malfunction if there is a conversion error between the foot and the mile? In the U.S., pounds and kilograms of candy bags are sold side by side at the mart. For some reason, Americans prefer pounds of candy bags as opposed to kilograms of candy bags. Why should that change? It's not at all important. Meaning, the metric system has no association-based meaning to its units. It was designed purely for mathematical purposes without visualization purposes in mind, which makes it harder to commit to memory, whereas the imperial and customary systems have association meaning to their units. Historical purpose. The imperial and customary systems use a different arithmetic standard than does the metric system. This standard is older than the decimal standard. For some, it's actually much more intuitive than the standard which is used by the metric system. This standard type uses multiples of base units with various integers to get new base units for different scales. For example, and now the modern commonly used units. Similar lists apply to weight, area, volume, etc. It may seem convoluted at first glance, but in each case, each unit is itself a tangible, useful thing. A rod actually means something and is useful. So does and is an inch, a foot, a yard, a pint, a gallon, etc. Each unit was designed for a particular range where it is the perfect unit for humans. In history, a furlong is the length of the field at which distance you turn the oxen around and head the plow back the way which you came. 1 furlong long by 1/10 a furlong, aka a chain, aka 4 rods, aka 22 yards wide, is a day's work, aka an acre. The foot measurement is close to the average adult human foot, with a shoe on it, that is. A pound is a standard loaf of bread. A gallon is a large flagon of wine. A pint of water is a pound of water. A teaspoon is the spoon with which you stir a teaspoon of sugar into your tea. Fahrenheit, from 0 degrees to 100 degrees, represents the average range of weather per year on the mainland of the U.S. and in temperate climates on average during the year, and is also the range which humans can tolerate. On average, very rarely does weather temperature exceed or underseed this range. The imperial system's concepts, philosophies, and principles are, in fact, so useful that here we use unofficial units when talking with our friends, families, or even co-workers. We don't say to Mom that we need 6 gallons, but rather 3 jugs of fruit punch for the party because the jug is the container in which the drink is contained. Or if I were to say to my coworker that I need 12 large buckets of water and 5 squares of steel for the job, he knows that I need 60 gallons of water and 5 1.5 yards by 1.5 yards steel sheets because they are the materials with which we work regularly and have a common association with. Jugs, buckets, squares, stories, etc. may not be officially a part of the imperial/customary system, but we use them because they are the most accurate units for the intended tasks and are based upon physical associations which we humans are tuned for. Now then, you could plow for 201.168 meters by 453.5 grams of bread, 3.785 liters of wine, put 5.69 grams of sugar into your tea, or use a temperature range of -18 to +38. Even though these are perfectly valid, they aren't nice, round, simple integers for humans to work with, and also, it's just not the same. So in closing, the imperial and customary systems are for human beings, whereas the metric and SI systems are for android robot computer calculator machines. Of course, that was an analogy and metaphor to help better communicate my point. Obviously, either a human being or a machine can effectively use either system, but the imperial/customary system is better for human beings and their everyday lives. So what's the big deal? Thank you.